we want to solve this rational equation. We have a rational expression equaling another rational expression. And what we're going to do to start this is to find the LCD. So the LCD here is going to be x plus 3 times x minus 5. And now our plan is to multiply both sides of this equation here by the same number, and that number is going to be the LCD. So we're going to write the LCD here on the left side, here on the right side, and we know that if you multiply both sides of an equation by the same number, that new equation is equivalent to the original. Now, because we're going to multiply both sides of the equation by this number right here, we just have to be sure that we're not multiplying both sides by 0, right? We can multiply both sides of an equation by any number except 0. So we need to ensure that this is not 0. So what's going to make this 0? Well, we can tell that. We're going to say x is not equal to negative 3 or positive 5. So as long as we exclude these two values, we can multiply both sides of this equation by this number right here and have an equivalent equation. So let's do that. Let's write the LCD on the left side, x plus 3x minus 5 dot, the left side, 12 over x plus 3 equals, okay, the LCD, x plus 3, x minus 5 dot, the right side, 7 over x minus 5. And now you can see what's going to happen here is that this denominator here is going to cancel with that factor up here. That's the whole point of multiplying by the LCD, is that it helps us to eliminate all the denominators. So let's cancel this one. And doing so, we're going to be left with 12 times x minus 5. So we'll get 12 times that x minus 5 equals, and now on the right side, this x minus 5 cancels with that x minus 5. Let's do that. And now, doing so, we're left with this 7 times the x plus 3. So let's write that, 7 times x plus 3. And now we have a nice equation that has no fractions in it. Let's just go ahead and solve. So we'll multiply through here. We'll get 12x minus 60 equals 7x plus 21. Why don't we get all the x's on the left side, since we have 12 over there and only 7 on the right. So we'll subtract 7x from each side. 12x's minus 7x, 5x minus 60 equals 21. Let's add 60, right? So the plan now is to add 60. So we'll get 5x equals, now we're going to add 60. That'll give us 81. And then we're going to divide by 5. So we'll get x equals 81 over 5. Now, just run a quick check here. This is what we're going to say x is. Now we have to come back up here and be sure it's not one of our excluded values. The values we were excluding were negative 3 and 5, and we, if we did everything right, got 81 over 5. So it looks like we're okay. So we're now going to claim that that is the solution to our equation. Let's get started on this one. So what we need to do first is find the LCD, and we need to do that by factoring this denominator right here. So let's rewrite everything with that factored denominator. So 7 over x plus 5 plus 3x over at x minus 2 equals, okay, 42 over, now this is probably not going to be a surprise, but look at this denominator and look how this is going to factor. It's going to factor as x and x, maybe a plus 5 and a minus 2. So our LCD is x plus 5, x minus 2, and because this is an equation, we're going to look at the excluded values. So in solving this equation, we have to exclude these values, negative 5 and 2. So let's multiply both sides of the equation by this LCD. Now, imagine what we're going to do here. I'm going to take a little shortcut. Imagine this LCD on this side over here, so it's LCD times all of this equals LCD times this. But then on this side, the LCD times all of this, we're going to distribute. So what's going to happen here is that the LCD is going to end up in front of every original term. So that's what I'm going to do. I'm just going to put the LCD here, here, and here. So let's do that. So we're going to have x plus 5, x minus 2, dot, that leftmost term, 7 times x plus 5, plus, all right, the LCD, x plus 5, x minus 2, dot, that middle term, 3x over x minus 2, equals the LCD, x plus 5, x minus 2, dot, that rightmost term, which is 42 over x plus 5, x minus 2. And now, looking back over here, you can see that these x plus 5s are going to cancel. And that's the whole point of doing this, to get those denominators to go out. So let's cancel those. And then doing so, we're left with that 7 times x minus 2. So let's write it. 7, x minus 2, and then plus. Right, there's the plus. And what happens over here in this middle term? You can see that the x minus 2s are going to cancel. So we'll cancel those. And doing so, we're going to be left with that 3x times x plus 5. So we'll write that. 3x times x plus 5. And that's going to be equal to, now on the right side over here, that denominator cancels completely with this. So we're going to get that big cancellation, this one, and we're left with 42 times 1, or just 42. Now, let's just multiply through here and get this equation solved. So multiply through, we'll get 7x minus 14 plus, now multiply through here, how about 3x squared plus 15x equals 42. Now, this is going to give us, I see this quadratic here, so I'm going to write that first. So this is going to give us 3x squared, and then we've got 7x, and 15x is a 22x. And then, what have we got here? Minus 14, so let's go ahead and write that one. So minus 14 all equals 42. So it's quadratic. Let's get everything on the left side. So let's subtract this 42. So doing so, we will get 3x squared plus 22x. Now, negative 14 minus 42 is a minus 56 equals 0. And we know what to do here, right? It's quadratic. We've got everything on one side, 0 on the other. So we're going to factor. So you know what? I'm going to do that way up here. Okay, I've got it started already here. So we're going to have 3x and x. And then we need to deal with this 56. So what can we do here? With this 56, maybe we could do this. That 56 is 56 and 1, 28 and 2, maybe 14 and 4, even 7 and 8. All right, so I paused things a little bit, and I tried some of these, and here's the pair that I'm going to use, 28 and 2. You can try these others, but you're going to find that they don't work. So what I'm going to write here is the 3x and the x, and then I'm going to put the plus 28 here and the minus 2. Or it's not the easiest factoring that we've done, but after a few tries, you'll get it. Now, what's going to give us 0 here? So from this one, we're going to get x equals negative 28 over 3, and from this one here, we'll get a 2. Now, we think we've got our solution here, but let's just check back here. Here's what we're claiming the solution is, or we think it is. But follow it all the way back to excluded values. What values, if any, were excluded? Well, we excluded negative 5 and 2 because negative 5 and 2 are going to give us 0 back in the original rational equation, and that's going to make it undefined. So we had to exclude negative 5 and 2, but look what we're getting over here. We're getting a 2. We need to toss that out. And the only thing we have left then is this negative 28 over 3, so we're going to conclude now that x is equal to negative 28 over 3. So we thought we had two solutions, but really we had only one. Let's see what we can do about solving this equation for x. So we have the LCD. Well, we can get it, right? The LCD here is x plus 5, and as long as x is not equal to negative 5, we should be okay. So let's multiply both sides by the x plus 5. So I'm going to write the x plus 5 here and here. Let's do it. It'll be x plus 5 times a equals x plus 5 dot b over x plus 5. Now let's multiply through here. We'll get ax plus 5a equals, and on the right side, the x plus 5's cancel. Let's get rid of that then. So we will get b times 1, or just b. Now we want to solve this for x, so let's subtract the 5a. So we'll get ax equals b minus 5a, and now let's divide by that a right there. So that'll give us x equals b minus 5a all over a. Now if you did this slightly differently, you could have gotten this, b over a minus 5. Both of these are equivalent.